Hello, good evening, everyone. My name is Manas, and I'll be the host for today's online workshop session. It is a pleasure to have you all here. Let me introduce today's speaker, Raj Sahu. Raj is a fourth-year student of Integrated Master of Technology in Applied Geophysics. He has a keen interest in machine learning applications in geosciences. He is also an upcoming intern in British Petroleum in geophysics profile. He brings a unique perspective to today's session, and I hope everyone learns and gains knowledge in today's session. Please ask your questions at the end of each topic or at the end of the session. So let's get started right away.
Yeah, so hello everybody. So I am Raj Sahu, as Manas has already introduced me. Yeah, so I'm audible clearly.
Yes, very clearly.
Yeah. So it's an exciting opportunity to present my perspective on machine learning in geosciences in front of you all today. So let's start today's meeting. Let me share my screen first. So is my screen visible?
Yes, it is. Yes, it is.
Okay. So let's start. So as you already know, today's topic is Introduction to Python and Machine Learning for Geosciences. So I suppose when you all registered for this course, at the end of the Google form, there was a video for Python's basics. So you must have already gone through it or have some knowledge about Python. So I will not cover total basics of Python, like what is the syntax, how to write an array, how to calculate mean and these things. So let's start. So today's itinerary will be having introduction to Python basics like NumPy, Pandas, and Matplotlib. Then we'll start with basics of machine learning. Then we have some case study. We have two case studies today. One is for gravity data, another is for self potential. And then the advanced topic. So case study and advanced topic, I've merged them slightly. So let's see how it goes. Yeah. If you guys have any doubt, you can put it in the chat or we can discuss it later. So let's start with introduction to Python in geoscience. So as you all know, Python is a very powerful language and it has many uses. So in the field of geophysics also, it is very useful. In geophysics, we have a lots of data. So to process it, we need some kind of tools, be it software or anything. But Python comes here and it plays a very good role because with Python, you can easily manipulate your data and do anything what you want with it. So in geophysics, since we have very large quantities of data in TBs and GBs, we need some data-driven methods. So in starting or in earlier times, we used to have formulas and traditional methods like conventional methods. But nowadays, since ML is so trending, we have also started applying ML in Python in geoscience also. So let's see today how we apply in geoscience ML topics. So let's start with basics of NumPy. So as you all know, NumPy is a computing library in Python where you can create arrays or do calculations and do many other operations such as statistics operations, stacking matrix operation, linear algebra. So today our main aim will be near arithmetic and mathematical operations. Yeah, so let me also share the link of this slide, this collab with you all, so you can also go through it side by side with me. You can all copy in your drive and do with me side by side. So let's wait few minutes for you all to go through it. So first of all, as we all know in Python, always start by importing the library. So today here we have already imported the NumPy library. Next is the creation of array. As you all know, this you might all be familiar with also. So creation of array, creating 2D arrays. So here it is. Yeah. So all of you, have you all opened the collab link and copied to your drive? You can react by thumbs up or anything. Yeah. Okay. So you can do it side by side to me as I'm speaking. Yeah. Are you facing any problem? No, then okay. Yeah. So creating array is very simple, np.array, and then creating 2D array is also simple. We just need to add parentheses to it. Next is the basic mathematical operations like addition, multiplication. Next, we also need to create some arrays like zero array, identity matrix, or some random arrays. So here we can see as we have created zeros. Let's say I change this to 5. So here we have 5 by 3 matrix of ones. Next is the exercise. I hope you all can do this, creating a 4 by 4 matrix. So it's easy. Let's say array 1 is my. Here we want to create an identity matrix. So we will use once the shape of it, which is 4 by 4. Yeah, so you need to keep in mind that we need to also keep it shaped like this. So here we have created a 4 by 4 matrix. Next, we need to create an array of 10 random numbers. So I'll name it as array random. So to create this, there are many options. Either I can take random numbers, random integers, or random with some variations like linear variation or Gaussian variation. But today I'll take totally random, and the size is 10. So we can see we have this array of size 10, and to create its mean, we can simply use np.mean. So we can see the mean of our array is this. So this was our array and this is our mean. So it's very easy in NumPy to manipulate the data numerically in terms. So this was the basics of NumPy. Now let's get to Pandas basics. So similar to NumPy, Pandas is a very important library in Python. So Pandas has various uses. We can use it to import data from different kind of files like CSV files, Excel files, text files, data files, shape files, or any kind of file you can think of. Almost all of them are, we can import them in Pandas. So Pandas uses data frame as a data type. So it looks something like this, where we have this purple box you can see is the data frame and the red box is series. So here this total night charges, total internal minutes, total international calls. These are all called columns. And this for this series, this is the column name. So we have imported the pandas. So for data for this pandas course will be, we are taking it from here, this website. So at GitHub, I found this diamonds.csv file. So it is useful. And you can also see to import the data, we are using pd.readcsv. So readcsv means the data is in CSV format. And for its location, we are taking URL. If I had a, let's say a local file, I mean, not in the web path, so I can easily just put its file name, file path. But since we are using online, so we will not use file path. So as you can see, I've already printed some of its data. It includes carrots, cut, color, clarity, depth, and price. So this is all about the data. Now look at the pandas function. So pandas contains many functions. So we can divide them into majorly three categories: data importing, data cleaning, and data statistics. So data importing, as you can see, pandas.read CSV, table, Excel, SQL, JSON, HTML. So these are all for importing the panda. Pandas.data frame, it creates this data structure, table like. And pandas.series is a part of this data structure. And you can also see date range. It is used to handle dates. We also have date time function. There are many such functions. Concat, pandas.join. These functions are used to join the data frames. Let's say you have array 1 and array 2 or data frame 1 and data frame 2. You want to join them based on the index. So you can use this function. Similarly for cleaning, let's say you have some empty boxes in here. Let's say there is a none value. So you want to fill them, you can have pandas.fill NA, pandas.drop NA for dropping the values sorting to apply. Pandas.apply is a very unique function. I mean, it is very useful function. Let's say you have this price and you want to add rupees in front of it. So you can use pandas.apply function to apply your functions. You just specify a function and use this to apply on it. Pandas.group by append. We'll see their uses later. So I'm just stating their functions. Pandas.join rename. So we have already seen to save into CSV file, we can just use pandas.toCSV, similar to read CSV. And for statistics, we have same functions. Now let's see data exploration basics. So we had the data named as df variable here when we read it. So here we can see the statistics, the data exploration. So you can see what are the column names, what are their values, their count, are they null values or non-null values? It means that is there any data missing simply? And their data type like float, object, int. Float means it may be a decimal value. Object means it must be just a any value. It can be a string type or numerical also, but in string format. So this was all about it, and we can see it is 4.1 MB plus. So next is the data.describe. So here you can see for describe we can see count, mean, standard, minimum, 25 percentile, 50 percentile, and other criterias. So it shows how your data looks just to see statistically. Now let's say I want to select some columns and print them, but I do not want to print these values. Or let's say I'm just selecting cut and price. So this is the syntax, as you can see, df price cut. You need to keep in mind if we have multiple columns, so we need to add another bracket here. Otherwise, single will be sufficient. So if I remove this head, so you can see we can see the whole data frame. But we generally prefer head just to see the top values. If I use head 3, so it will show only top 3 values. So this is how it is done. Now let's say I want to know the value counts of the cut. Because it is a category variable, you can see we have ideal premium, very good. In the original data, where it is. Yeah, here it is. So you can see there are different types of cut. So I just want to know how many ideal cuts are there, how many premium cuts are there. So to do that, we use value counts function. So as you can see, I have just written this code, and when I run it, it shows me there are 21,551 ideal cuts. Fair are the lowest and ideal are the highest. So it also is in the descending order. Next is, this is a very important function. From this function, we can know is if there is any missing value, and we can just sum it. Because if I remove this sum, it will be like this. So I don't want to see because I can see only few variables. So we use this variable just to know how many data values are missing if there was any. Now next we can see we can also use inbuilt plotting function of this pandas library. Here we have, as you know, in here I have written df.plot. So here I have x equal to caret, y equal to depth, and kind equal to scatter. Scatter means this is a kind of scatter plot. If it was another kind of plot, say histogram, I would have used an hist word, or KD for KD plot or line plot. Next, I am using C price for the color. So as you can see, this red and blue, the color map is based on the price, and the color map is jet. So as you can see how carat and depth varies and how the price is affected by it. If I change my jet to Inferno, you will see the color map has changed. So it is taking a time actually. Yeah, so you can see this is changing very much. So color map is also very important in Python plotting because for different kind of data, you may need different kind of color maps. Let's say graph or seismic or any kind of data maps. For geoscience, importantly, you may need seismic, Inferno, Jet, or Viridis. Viridis is the inbuilt one, the default setting. Next, we have filtering. So as you can see, filtered data frame Here, this is the syntax for it. So you need to keep in mind that first we use the data frame name and bracket, and inside that bracket, there is another. So this is the series and it should be greater than 5,000. So I'm taking price which are greater than 5,000. So as you can see here, all the prices are greater than 5,000. Next is the aggregation. So here we have used group by functions. Let's say I want to group all the data by cut ID by the cuts. So let's say all the ideal values will be in a one row and other values like good or premium will be in the other rows. So then I've taken the price for each of them and mean them. So I've taken the average for fair price, average of good, average for ideal, average for premium and very good. So as you can see, very good is ideal one is the cheapest one and the expensive, but this is the premium one. So this is what we can infer from the mean function. So this is an exercise for you to try. Load a different data set. I have already given the data set. So this is a telecom churn data. So it will contain information about the data calls like international data, time of the data, whatever. So we will use this data in the matplotlib. So just for you guys, you can also do this by yourself later because now I'm going forward. So next library is the matplotlib. So matplotlib is, let's say, the heart of visualization. So whenever you want to visualize anything in Python, you will be surely using matplotlib. There are also some other libraries. They are advanced one like Seaborn, Plotly, but they are also made out of matplotlib. So this is, I have attached a cheat sheet. So you can refer to it if you want some time, like what is the quick start, what are the subplots layout, and what are the different types of plot, scales, tick. Yeah, so I've imported matplotlib and Seaborn. So as I was telling about cheat sheet, so you can all refer to it for yourself. So next we have imported the telecom data. So this is the data. As you can see, it has many columns. Next is the basic statistics I want to know. So first of all, I'll do data.info to see what kind of values are there or what kind of variables are there. Let's say this is bool variable, I mean true or false. Here we can see it. Next we have object in 64, float 64. There are different kind of data types. And these are the column like state, account length, area code, international plan, total international charge. There are so many columns. So now I'll see data.describe. So as you can see in count, all the values have same count. It means there is no missing value. And you can also refer to different values at what is the total call stage. So minimum mean was 100, standard was 20 standard deviation, and maximum was 165. So now we'll start with basic plotting of matplotlib. So as you can see, we have different kinds of plot, histogram, bar plot. So first start with histogram. So as you can see the syntax plt.hist and the x value, I mean whose histogram you want to plot, and the bins. So the width of this each bar is 30. So this is what meant by bins. You can change the color. I can keep it red. Yeah, so like this. Alpha is just the, what I can say, the it makes it little transparent. So if you want to have another plot on top of it, so you can easily see it. So it affects the transparency of the plot. So this is all the X label, Y label, and title. Next is the bar plot. So it is also similar to it. So we are using, first of all, for bar plot, we need to have the different counts of the variable. So we have taken churn counts, which was true or false. So we have using df.value counts function. Then we have used plt.bar. So it is similar to histogram. We just need to know the difference between histogram and bar plot is that histogram visualizes the frequency, whereas the the bar chart is all about counts. So it is the difference. I hope you remember it because many people get confused by it. Next is the scatter plot. So it is similar to a normal plot, just instead of connecting all the lines, we use dot in it or say dots. So here, as you can see, the value of alpha is 0.5. So if I increase it, or let's say I've decreased it, so we can see there are many overlapping points here and less overlapping points here. So this is what meant by alpha. If I increase it, so their intensity will change. So here you can't see any difference on the overlap. So keeping it between zero point 0.4 to zero point 0.3 is good for general plots. So this is what is scatter plot. Next is the box plot. Box plot is also important because it gives you information about the outlier. So as you might have read in the statistics, we have quantiles like 25% quantile, 50% quantile, and 50% quantile is also known as median. So this line is median, green one. This is 25% quantile. This is 75% of value. So where we can find it, you can see here in describe this 25% and 50% and 75%. So these are all three lines. And this bar, so distance from this 75% to this bar is 1.5 times of this interquantile range. So although it is not important right now, it will be beneficial to you to know it. So these are the outlier values which we can if we want to. So next is the subplot. As you know, we just let's say I want to draw multiple plots side by side or up down, not just a single plot. So I will be using subplots. So as you can see, I've plotted 4 plots side by side. So for the syntax for it is there are many methods to plot subplots. Like one of this is using this, or I can just simply define plt.subplot, and I want to do it for this occasion. So 2 rows and 2 columns and first plot. So this I can also use it like this. So we will use it later. For now, we will look at this. So I've created a figure, this whole canvas and the axis. So axis is an array of 4 variables, axis 1, 2, 3, 4. So it is similarly like a matrix, the indexing of it 0, 1, 0, 1, 1, 0, and 1, 1. So we can just use this instead of PLT and then continue with our plotting. So this is what is all about matplotlib. So there's also contour plots. So contour plots are very important. Let's say you have 2D data and its variation. So you can use contour plot for it. As you can see here, I have a graded data, total day minutes and total day charge, total night minutes and total night charge. And on this design, as you can see, it is a contour value. So let me explain some of the code for you. We have taken X and Y from day charge, day minute, and we have created a np.mesh grid. So what does np.mesh grid do? It creates a mesh grid or a 2D grid, as you can see. It can also be 3D if we give the input parameters. For here, I have only given 2 parameters. np.linear space, this is a 1 parameter, and other one is this. So np.linear space, it creates an array ranging from minimum value to maximum value, and it is of length 100. So it will calculate the difference between them divided by 100. So that will be an arithmetic progression, or you could just say simply a straight line kind of array. So I've created a grid. So this is a synthetic grid. I mean synthetic data, not from the telecom churn. So I've created a sine cos function for this. So as you can see, it is reflected here. So for day, we have had this kind of sine cos function, and for night, we have having this kind of function. So this is about the contour mapping. So where contour is important, for it, the syntax is X grid, Y grid, and Z, and C map. So for scattering, we can also do it similar to it, where we need to define the C, and C means color, as I've already shown above. So it is also similar to contour plot, but it is not. Why? Because scatter plot will only be present where there are depth and caret values or the X and Y values. Whereas in contour plot, whole canvas will be filled, as you can see here. So here, as you can see, this is white because there was some data missing or the data length was not enough. That is why it is missing as, and you can see the values -1 to 1. So most of them are positive values. So here is another exercise loading the earthquake data. So this is an important data. Why? Because we all are related to geoscience. So I'll just show you here. So this is latitude, longitude, and magnitude. Let's say I want to plot it, just simply not by matplotlib, by using the pandas basic function. So I will use earthquake data frame dot plot, and the kind of plot, it should be scatter. As you can see in Google Colab also, you can get the pre-written code. It's like this. So it's a new feature like using ChatGPT, but I suggest you at least know the syntax of what you are using, because while debugging these codes, it becomes difficult if you don't know about the language. So if I plot it, you can see this is the latitude and longitude. So this was the, but I've not specified the color. So for color, I meant by magnitude. Now you can see the magnitude. So most of them are very medium ranged magnitude, like 5 from 5 to 7. As you can see, there are many, not many, I would say very few earthquakes having magnitude range from greater than 9. So let's say I want to know which earthquake has its intensity greater than 9. So I will just use it. Its magnitude should be greater than 9. So as you can see, there are only two earthquakes which happened in 2004 and 2011. So it is real-time data. So yes, in India in 2004 there was an earthquake, and in 2011 also. So this was its location. So this is how we use pandas and matplotlib combined to investigate any data. So, and better term for it is EDA. What is its full form is exploratory data analysis. So whenever you want to work on a data, be it a machine learning model or just some conventional way, you need to explore it, like how it is varying, what are its variation, mean, statistics. You just need to know it to get to know your data better so you can apply it. So next, we are done with the basics of Python. Now we'll start with machine learning. So if you have any doubt, you can put it on the chat. Uh, okay, this, yeah, we will be uploading this recording on the YouTube also in our channel, so you do not need to worry. Next is the fundamentals of machine learning. So as you all know, machine learning is a buzzword nowadays. Machine learning, AI, ML, everybody is interested in it. So machine learning is a subpart of an AI. AI is a larger word. Machine learning is a part of it. And inside machine learning, there is deep learning. So today we'll be focusing on machine learning and some of deep learning. So machine learning is also divided into multiple parts like unsupervised, supervised, reinforcement. So what I meant was multiple parts, not that some of machine learning is unsupervised, some of machine learning is unsupervised or supervised or reinforcement. It means that there are multiple algorithms in machine learning. Some algorithms are unsupervised and some are supervised, some are reinforcement. So what is the difference between unsupervised and supervised? You might already know. Supervised means we are giving the data labels and the target variable also. I mean to say, if I am writing the equation y equal to mx plus c, so I know the y and x. So I just need to find the slope and the intersection. Unsupervised data means I don't know the target variable. I just have some data and I need to find patterns within it. Reinforcement learning is generally used in games and this kind of robot kind of situations where we train the model by giving it some reward for every right answer and making some penalty or marking some penalties for wrong answer. So let's see its uses. Supervised learning is again classified into two parts, regression or classification. So regression means it is our data is continuous. We are trying to find its value at every point. Whereas classification, we are trying to classify our data into some classes. It may be few classes or there may be many number of classes. So as you can see, the application, population growth, estimating life expectancy, market forecasting, weather forecasting, advertising. And for the classification, it is diagnostic, customer retention, image classification, identity, fraud. So these are for the general purpose. I mean, in geoscience, there are also many, like let's say I have seismic data and I want to there, when we have surveys, so there are some kind of error, and because of this error or muting, some data may be lost. So if you in a seismic file you're finding you do not have a trace of you do not have few traces, so you can train ML model. So it will look through whole data, it will get trained and it can predict the disappeared trace or the missing trace. So it is one of the application of ML in geoscience. We will see further. Next is the unsupervised learning. It is all about the learning the patterns within the data. So clustering algorithms, we have a recommender system, target meeting, marketings, customer segmentation. These are all the part of clustering. Let's say whatever feed you get on Instagram, Zomato, Swiggy, YouTube, it is all part of these clustering algorithms. Next is the dimensionality reduction. So it is used because when we have lots of data and there is correlation between each feature in the data. So if I want to reduce those feature to save my computation and time cost, so I can use dimensionality reductions. So there are PCS, the very common dimensionality reduction. There are also other algorithms also. Let's look into reinforcement learning. So in geoscience, we'll be using it very less. I mean, there's not much use of it, but you can still use it. So game AI skill acquisition, and it is mainly used for robot navigation and real-time decisions. So next we'll come to how the workflow is for geoscience data or geospatial data. So we have geophysical components like planet, satellite, atmosphere, geological model, oceanography, earthquake, volcano, whatever, and our Earth. So we have many data or many geologic bodies or features. So we observe them through our instruments like or methods like we have satellites. We can also do it airborne. We also have observatory, or we can just use by a sensor or other methods. So when we keep this data or we acquire this data, so we are left with the data, but what should we do it with it? Our main aim is to image the subsurface or find the features in the earth which are beneficial to us or which we are intended to find. So here we have training data for we have the training, so you can see we have deep learning, support vector machines, many other algorithms which we use for training. And next we have induction. So what is induction? It is model driven. These are all based on physics. So this was the conventional way, but now we are using ML way to infer the models, the subsurface. You can see earlier it was we used to in we used induction using these algorithms, these theorems, physics-based theorems, and we used to deduce the Earth. Now we are using ML for inference. Next, we have the Scikit-Learn. So Scikit-Learn is a very common library for ML in any domain. So you have Scikit-Learn algorithm cheat sheet here, which you can see. We have regression, clustering, classification, and dimensionality reduction. So there are many types of algorithms in it. You can use any of them. So I'll show you few of them how to use. You can refer to them later. So here we have well-log data. So now we'll be using only geophysical data, no other stream. So here you can see we have depth, self-potential, gamma ray, caliber, bit size, and many other logs. So I've taken it from this GitHub. You can also refer to it later. So this is the data. Now I also took the well tops location from there also. So it was there one of its notebook. So next, what I want to do, I want to make a triple combo plot. So as you might already be familiar with triple combo plot. So let's see, this is the code for it. It took a time to write it. Actually, I copied it from somewhere, but if you want to write it is a bit large, but nowadays there are lots of codes in GitHub, so you can easily find it. So this is how we used, I already explained you how subplots are used. So as you can see, we are creating a subplot with one row horizontally and three columns. We can also specify the figure size, and share y means the y-axis, its values will be shared. So let's see how it looks like. So this is the triple combo plot what I have drawn from with the help of this function and data. So as you can see, it takes three inputs: data, the data frame, the minimum depth and maximum depth. So here the data map is the minimum from the data and maximum from the data. So I have not specified it. So it's just from the data. As you can see, we already specified the well tops, so Barrow sandstone and TS Sang River sandstone. So there are different tops. So this is all how we use Matplotlib to analyze our data. There are many steps you can do. You can find volume of shale. You can find porosity, permeability with the help of this. But today we are not looking for that. I'll continue. So here we can see when I used isNull.sum, there was this variable was missing. We also have one more variable missing. I can't find. Yeah, so this was an bit size. It also was not needed here, so I dropped it. So this is the syntax for it. Next is the data.describe. So it's the same as we earlier saw. So if you want to know the count or mean, standard deviation or minimum maximum, so you can refer to this. So next is a very important plot, correlation plot. So it will take a time to plot because it is a large one. Yeah, so we have used here a word SNS. So what is SNS? SNS is the short form for seaborne we earlier imported. So this library is used for when we are making some complex plots or advanced plots. So I've created a heat map. As you can see, this 2D grid. So I have correlation data in the first and we have annotated. So you might already know the meaning of this. We have the variables or the columns in the X and Y and its correlation with other columns. Let's say SP and I want to know phi. So SP and phi are correlated negatively 0.76. So it means that they are good. They are not correlated with each other and we can easily use them for our machine learning algorithms. But when we are having one, so this one is because of VC LRT and it will be same for this side also. But here also we are seeing some 1 1. So it means that this is also correlated with this feature and it is not good for a ML algorithm. So we need to avoid these kind of ones or we can drop them and we need to look for zero correlation majorly or negative correlation. So here I have the data dot columns and next we'll be training our data. So as you already know, let's say I have this whole bar of data. So I want to divide it into two parts, training and testing. So training, I will train my ML model to learn that data and I will test on testing data. So I have pulled out the sample from the data. And I can also do it like this while I'm training. I also check the efficiency of the model. So I can create a validation part. So training, validation, and testing. So we can divide it into three. Here I've only used training and testing. So it is generally, let's say 90% training, 5% validation, 5% testing. If you have very large data, if you have some small data, let's say in thousands, you can use 80% training, 10% validation, and 10% testing. So this was the workflow. So here I've started using Scikit-Learn libraries. So here we are using in Collab, so it won't require any importing part. But if you are using in your laptop or using VS Code or Jupyter, if you want to use it for the first time, so you need to import it. So you will be using like this SCIKIT. So this is the code for importing Scikit-Learn library if you don't have, but here we will skip it because you already have it. So next is the data.shape. So this is the previous well log data which we had here. So what I've done here, I've created another data frame named df, and I've created it from df.copy. Why we use it generally? Let's say you are using some pre-processing or processing your data, you want to change some values, and if you're afraid that original data might get changed, so you just use the copy function to create a new variable. So as first of all, we will look for regression, and it is a supervised algorithm, so we need x and y. So we are trying to predict here RHOV means density, bulk density we are trying to predict here. So first of all, to create x, we have dropped the bulk density, and for y, which is our target, we are taking the bulk density. As you can already see here, it has high frequency in the 2.5 range. Rest are around it. So next we are splitting the data. So we have here x train, x test, xy. So here we use this function text string split to get the data. So here I have specified my test size as 20.2, which is 20%. And I also use random state because it is a seed variable. Whenever you are trying to replicate, because it will divide our data into 80 to 20%, but it will not be in order. Let's say first 80 will be train and next 20 will be test. It will choose randomly. So if I want to use my code again and again or share somewhere, so I will use a seed variable. Here it is random state. So I can give it any value like 42, 35, anything. I'm using it 42 here because if you are also using alongside me, you will get same results. Next is the standard scaler. It is important for models like SVM, KNN, and neural networks. So what is standard scaling? Let's say you have your data ranging from 0 to 100. So it is very large range. But generally for ML models, we like values to be ranging from -1 to 1 or 0 to 1. So it normalizes or standardizes our data. So as you can see here, we have used fits, transform, and transform. So these are all from Scikit-Learn only. Here you can already see. So this is where Scikit-Learn comes into play. As you already might know, linear regression. We have a straight line. We are trying to predict y. We have the target variable y and data variable x, and we are trying to find theta 1 and theta 2 value, which are the intercept and slope of it. So we use, there are many methods, gradient boost, gradient descent, and we also have loss function for it. Mathematical way we can also find, but here in Scikit-Learn, we don't need to know all these things actually. If I want to just apply linear regression, I just need to import from scikit-learn.linear model this linear regression, and I need to explain it. Or here I've named a variable named LR, which is linear regression, and this I need to fit it. And I've also predicted on test. So we'll later see how it looks like. First, we'll go through the other algorithms also. So next is the random forest. So as you can already see, first, before knowing random forest, we need to know decision tree. So in decision tree, it looks like decision. Let's say it will predict or classify data based on decisions. Like if a variable is greater than 5, then this will happen. If it is greater than 4 or less than 5, this will happen. So it is like this. And to know this, to test it, whether it is which variable to choose first, it uses Gini score, which I have not included here because it was not important. So random forest is advanced version of decision tree. It uses multiple decision trees to into consideration, takes their result and uses majority voting to find the final result. So similarly, we have used random forest regression. Now I've here specified some hyperparameters, actually number of estimators, or which is 100. So it will take 100 decision trees and then estimate them. Similarly, next we have support vector regression. So in support vector regression, we have a data we want to use regression on it or classify based on the main line and the hyperplane, which we call as support vectors. So we need to find the distance between these two lines, which is called as maximum margin and minimum margin, or maximum margin only. So yeah, so when we find these two lines and create the boundaries, so a vector machine will be ready. So I will not go into its maths. Next we similarly train it. Now let's see the result. So as you can see, I was trying to predict the bulk density. So bulk density, it was varying linearly, and this is my predicted bulk density. So you can see the dotted line here in black is the original density, and here colored scatter plot is the predicted one. So linear regression is working fine, random forest is also working fine, but support vector machine is not working. So in this case, we can see support vector regression is not suitable for predicting bulk density. It may work on other well-logged data or other variable, but it didn't work for this case because we have actually not featured any variable. We took all the variables, all the logs present in for the ML model. So it is not actually done like this. We remove some variables, remove some logs. We just take normally the major logs like gamma ray, VPVS, porosity, permeability. We just take these logs to predict the other variable logs. So next we can see if we want to know how much good of it is working, like its accuracy or other. So we have other metrics like mean absolute error, you might already know, mean squared error and R squared or coefficient of determination. So it is also available in Scikit-Learn like this, mean absolute error, mean squared error and R2 score. So you don't need to know all the mathematics behind it. You just need to know the use here and you can just work on it. So we can easily see for linear regression, the performance was very good visually, but I don't know how it is mathematically. So I will see here its mean average MAE is very less, e to the power minus 16. So it's just zero. R2 score is also one. It means it is predicting 100%. Similarly, for a random forest, it is also 0.99. But for the support vector machine, it's 0.85, 85%. So as you can see here, there are some variations which it couldn't predict. It is why because support vector machines are generally used for classification, not for regression. Sorry. Yeah, so support vector machines are used for classification, not for regression. This is why it wasn't working well. Now let's see for classification. I've created a new variable called row density. It means density category. So I have divided it into three parts based on low, medium, and high. So if let's say density varies from 2 to 3. So from 2 to 2.3 it will be low, 2.3 to 2.6 it will be medium, and rest will be high. So similarly, I've created X class, Y classification. Similarly, I've made train test split. Here also it is 0.2. Next is the scaling of it. Next, we will look for the different classification algorithms. So the first and the foremost is logistic regression. So its name is regression, but it's actually classification algorithm. So do not be confused by it. So we have logistic function here. We can see it works on the, let's say I input any, for the linear regression, as you might already know, it was y equal to mx plus c. So here we have, it is slightly different. So sigmoid function is, it takes, this is my data part, phi t into x, phi t is the model parameters. Next, for sigmoid, it is 1 by 1 plus e to the power minus x. So if it is, this whole part comes 1, so it will be class 1 or class 0. So it is binary. But we can also make it non-binary by using multiple classes. If we keep it like if it is from 0 to zero point 0.1, it is class 1, zero point 0.2 to zero point 0.2, class 2, and so on. So we need to decide it on ourselves. But generally, if it is greater than 0.5, it is class 1. If it is greater than it is less than 0.5, it is class 0 or another class. So this is how it works. So here, similarly to the regression one, we use for the classification one, we are importing logistic regression, predicting, and we can see the classification report. So this is a good function in Scikit-Learn. You don't need to find the accuracy score or these what I was saying, the mean average error or these things, because they don't work in classification problems. They are only suitable for regression. For classification, we have the classification report. So as you can see, we are taking precision, recall, and F1 score. What is precision? It means that if it is predicting a certain value, so how many times it is repeating the same value, or how similar it is, and recall means how many values are correct. F1 score is also based on precision and recall. It is the harmonic mean of them. So as you can see, it is performing fairly well. It is like precision is good for low, it is high precision, and recall is perfectly one for low, accuracy, micro average. So this is all about it. Next is the random forest classifier. It is similar to decision tree. I mean, decision random forest regression. It takes classes instead of regression at last. So we won't go into its maths. S- So it is also quite good. I mean, it is better than the logistic regression. As you can see, we can see many ones here. Next is the support vector machine. So it was for classification, we use support vector like this by creating a horizontal line. If we have polynomial classification, like not just one class, multiple classes, we don't need to, our data is not linearly separated. So we can also do it like this. The hyperline can change. So it is happening automatically. We don't need to define this. So here we can see it worked quite poorly compared to random forest classification. So it was the best for among three for us. Next, we'll look into the case study. So this was all about machine learning. I won't go into too much basics because or too much advanced because if you try to do it on all in one day, you can't get enough. I mean, you will forget many things. So let's go for the geophysical data processing. So first of all, here we will try to predict subsurface properties. And what are the general steps for it? Let's say we have log measurements, seismic attributes, or resistivity data. These are the common geophysical data that we have with us. Next, we want to process it, like handling missing data, normalization, scaling, feature selection, encoding. What is encoding category variable? Let's say initially for the diamonds one we had, or let's say for this resistivity, not resistivity, density, bulk density, we had low, medium, and high. So instead of for model, everything needs to be in numerical format. So instead of low, medium, high, if I like give it like 0, 1, 2. So that is one kind of category encoding. We also have one hot encoding, one multiple feature encoding. There are different kind of encoding. I will not go into it. Next is the model interpretation. So like once you have created the model, you need to visualize it, 2D visualization, 3D visualization. It all depends on you. So by using general workflow, this kind of you can get into machine learning. So next, see here we will use 2D gravity anomaly detection using machine learning. So as you might already know, mathematical model for gravity. This is the formula I'll be using for generating the data, and I've also added some random noise here. So we will be using three model logistic regression, support vector machine, and random forest classifier. So we'll be splitting the data into 7:3 ratio. So this is the function for generating gravity data. You can also use any function you like. It doesn't need to be gravity. It is just for purpose, tutorial purpose. So I've also added some noise here. As you can see, it is a normal Gaussian noise. And I've also introduced an anomaly. So let's see, we have created this function. Now we are using this function and we have x, y, and gravity. Now the data was, let's see later. So what we will do, we have x, y, and gravity, these z values. So we need to make it into features and labels because we want to do a supervised classification and regression problem. Be it any one of them, you need features and labels. So for features, I'm using column stack. It is a 2D data, so it will make it into a single array, 1D array. So this is the code for it. Although it looks hi-fi, it is actually very simple. Ravel means it will make its shape from n comma 2 to n into 2 comma 1. I mean, it will just unfold the array. Same for the labels. Next, we are splitting it. I already told you how it is being done, train test split. So as you can see, our test size was 30%, so I've used 0.3. Next, we are using three models. I've already imported them. For support vector classifier, we are using RBF kernel. So I won't go into details. And we have 100 number of estimators. So as you can see here, I'm predicting So it looks like this. It is quite good actually. So what is this? This is the confusion matrix for an ML classification models we generally use, like logistic, regression, SVM, and random forest. As you can see, if the actual value was 0, then the predicted value was also 0, 652, 650, 650, 642. So this is in the majority. And it is also, it generally contains information about false positive, true false negative, and true positive, true negative. So this is the confusion matrix. Now let's visualize what we actually created. So this was a gravity anomaly. It was a 2D surface for the x coordinate and y coordinate. So this was my spherical body at some depth. I don't know what it is. And this is this black part, as you can see, they are the noises. So this was our data. Now we want to plot it. So I've also created an interactive plot here. So if you want to know the gravity profile, because as you can see, it was at the center 25, 25. So we are getting sharp peak. If I increase its value 29, so it is changing. So here it was all noise. So it is only between 20 and 30 that you are seeing some signal. So this is how it is, how the gravity profile is. Next, we already used ML models to predict our data. Now we are just seeing how they look. So as you can see in this part, the logistic regression didn't work actually. Why? Because it was a class-based uh, data. It wasn't like for linear or polynomial based. So it is a classification based because we have, let's say, class 1 here, class 2 here. That is why linear regression didn't, logistic regression didn't work because it was multi-class, not just one class. And for SVM anomaly map, you can see it is showing some result. And for the random forest, it worked best. You can even find the noises. So in this case, random forest worked well. So this is how, if you have, let's say, magnetic data, gravity data, self-potential data, or any kind of 2D data or 3D data, this is how you use ML to predict data or predict anomalies. So here there was no initial processing like for generally for gravity data, we have Booger anomalies, free air anomalies, air force correction. So there are multiple corrections you need to do, drift correction. So the data was clean, it just had random noise, so there was no need for it. But in real case scenarios, might be having those noises and effects also. First, we need to clear them out, then train the ML model on it. Or there are also some models which are specifically made to find out the noise and clear it out of them. You don't even need to use the Booger free air correction or these corrections. So it is nowadays very trending like seismic denoising. In it, you just input your seismic data and will output your seismic data without any noise. Earlier, we used to do like filtering techniques or using high pass filter, low pass filter, and many other Fourier transform also we used to use. Now let's go into advanced topics. So for advanced topic, we have neural networks. So it is the actually
Mm-hmm.
most trending
Mm-hmm.
buzzword. We have deep
So
learning.
before
Yeah,
hello. So before we move any further, we should stop and ask whether anybody has any questions or doubts. If someone has questions, they can type them in the chat box so that
yeah.
Raj can answer them.
Can you any address any books for basics for Python, ML, and geoscience? Yeah, beginners and pro as well. So actually nowadays a lot of content is available on YouTube. So although I have some books with me, so I'll send it in the chat or send it to you guys by mail. I have some books with me which I referred to earlier. But if you just search online Python basics or Python tutorial by topic, you can easily get. There are many lots of playlists on YouTube, even for beginner and pro as well. And you can also refer to documentation of these libraries if you want. Do you about petrol in the classes? We have not, but petrol relates to this. Yeah, actually, petrol is a paid software for which industries use. So I have also used it. It is quite good. It can also do all ML works, but it is for s- what I'm saying, seismic data and these things. So it is very software. Actually, when we use software when we are in industry, or we do not have much time. Python coding is used when we are trying to explore the data research. So Petal is an industry software. We academics we use it less, but some of people are using it. So if you want to know about it, you can get to me by mail if you have any doubt. Are we getting Python notebook after the training? Yeah, I've already shared the link, so you can just copy it to your drive and you can get it. Yeah, so if you guys have any other doubt, you can ask. My mail ID, it was already in the LinkedIn actually. It is also at the end of the notebook, you'll find it. Any other doubts? Okay, let's start now. So last part is the advanced topics. So here we will be covering neural networks and how it is used. So let's say if you are using seismic inversion, so what is the conventional step? You have the velocity model, you have the geologic model, then you pick the velocity, you have migration, and it's a lot of headache actually. But if you want to use the ML to it, we can just input the geologic or seismic model, seismic data in as the X variable, and for the Y we can have some velocity models which have we have already created. So if we train on that, we can apply it into new data, so our work will be easier. Similarly, for gravity magnetic anomaly classification, I've already shown you. Seismic denoising also done like this. If we have a lots of noisy data, first we denoise it conventionally, then we create X and Y labels, and our model is trained. Then we can use that model on anywhere we want, in any new data we want. So for deep learning, there are few common architectures, let's say CNN, RNNs, and UNIT. UNIT is for segmentations, like fault detection. So I did some work on this. So for seismic fault detection, you need to have the fault segmented data also. Like if you have seismic data, you need to create another file similar which have the same shape as the seismic data, which can be used for fault segmentation. So it is the target variable actually. Next, we have spectral analysis and feature extraction. So these are all conventional works like wavelet transform, Fourier transform, spectral decomposition. This is how we use it. And next is the principal component analysis. Let's say you have lots of log data or many logs, and if you want to know, are these all required or are these all necessary for my ML model? Can I remove some of the logs? So there we use PCA to know the overall variance and correlation between features. Next, let's come into unsupervised classifications models or clustering model actually. So first is k-means clustering, DB-scan, self-organizing maps. These are all advanced topics. K-means is a common one. DB-scan and SOMs you'll find in research paper on many those kind of things. It is not generally used normally, but its application is huge, like detecting mineral deposits, identifying seismic facies, or segmenting geologic models. So here I've used PyTorch actually along with Scikit-Learn. So PyTorch is a dedicated library for deep learning. Here it has neural network module. So we'll use it optimizer, and we have also introduced k-means and PCA. So we'll be also using Fourier transform and IPY gets for interaction. So let's see, first of all, let's create a data. So I've already created the data. Now let's plot it. So this is how my size SP profile. So this is a SP data. So you can see like this. Currently, we don't know how the data looks like. I've just shown you the profile. So if I want to know how the data looks, I can just code for it. So we have X, Y, and Z. Let's say I want to map a contour map. So I'll use CU and TOU contour app. So you can see this is how the our data is looking like. So here we have Veritas. It is the by default one. So if I want to change it to Jet, Inferno, Or let's say there's also seismic color map also. It is used for seismic data actually. Here it will not work. We just go with inferloop. So this is how it is looking like. This is our x variable, y variable, x coordinate, y coordinate, and the self potential anomalies or values. So first of all, we'll apply Fourier transform it. We'll save the result, plot it afterwards. Next, we have the k-means. So k-means algorithm is similar like clustering the data. Let's say you have unknown data, you don't know the target variables or what it is representing. So you just see this cluster, and this cluster. So by algorithm, like finding the mean distance between points and allocating a center for it or cluster for it, we can create this kind of circles. So here we can see there were three clusters, 1, 2, and 3. Next is the implementation of here. So we have three clusters and we also applied PCA for it. First of all, although it was not necessary, I just applied it. It doesn't change anything. So as you can see the code, first of all, for PCA we imported it, and number of components we are taking 2, because for k-means at least 2 components are needed. If it is along a straight line, so there's no benefit of clustering it, so it won't even work. So we need at least 2 components for the clustering. So we have taken 2 components of PCA, similar to which we raveled it. Next we are creating the k-means. So next we have predicted also according to k-means algorithm. So we'll later see how it looks like. Next we have the PyTorch, like tensor data Gaussian filter. We have imported some. I'll tell you the uses of this. So this is how actually deep learning architecture looks like. We have our input x1, x2. It is going through some layer. It is multiplied some variables. We have weights, then their schools. Then it is passed by a activation function. Then we have some hidden layers. Here in this case, we have total 3 layers. So one first layer input, one hidden unit, another hidden unit, and lastly output. So as you can see, this variable is going through all the neurons. This variable is going to all the neurons. So this is a complex network with many weights we need to keep in mind. This is why deep learning is memory and computation expensive, but it works very fine. It can recognize any patterns you can't by eyes. Like if data is non-linear or there are complex patterns and models in it, so you can easily recognize it and predict. So this is the PyTorch model we have created. As you can see, first of all, in a general PyTorch architecture, we need to create a class by the model name deep neural network. We need to import nn.module. Next, we have this init class. We need to create all the initial variables for it, and then we create the forward. This is the default setting. I mean, you can't have forward or any other spelling. You just need to keep it forward and self and x. So this is the architecture similar to this I've created. Like first of all, it is going through an activation function for the BN1. What is BN1? Batch normalization, and its input is FC1. So FC1 is linear. So we have linear neuron, then batch normalization for it, then activation, then dropout. So it is like this, the multiple layers we have taken. Next, we are not using sigmoid here because it is a regression kind. Next, we initialize the model. So this was the creation of class, let's say kind of variable. Next, we create the model. We have initialized it. Then optimizer, I mean, how much, because what is the role of optimizer? It controls the speed of the algorithm, how fast it will converge or diverge, or how fast the error will be converged actually. So the criteria for this algorithm was mean square error. So convergement of mean square error, and based on it, it will update the model parameters. So this is generally the work of optimizer. There are many kind of optimizer, SGD, standard gradient boosting, also stochastic gradient boosting, Adam optimizer. There are many kind of. So learning rate here we have defined 0.005. So it will be good enough for this case. Next we have training data. So for PyTorch data, we need to define it into another kind of data type. It is tensor data type. So I've already created a tensor data type. So I've also applied Gaussian smoothing to tackle with noise. I've already told you this is a conventional way of doing it. Next, for these data, PyTorch has a specific kind of workflow you need to follow. First of all, you have the data, then you go through the forward pass, then you calculate the loss, then you update the model weights by backward pass and the upgrade network. So it works like this loop. So I've created a batch size. So the model will not take all the data together. It will take it in batches and then load it. So this was our data. We have converted it into tensor and then we have the data loader. So you don't need to go into details of this. The batch size depends on how fast, how big are the batches you want. If it is very big data or very large variables, so you can reduce the batch size. But here it was only two variables, so we have taken a very large batch size, 256 actually. And we are also shuffling it. So now let's look. This is the PyTorch training loop. So everybody should focus here. Why? Because we can't I can't remember all of this in my first time, so you probably won't. So for this PyTorch loop, you need to practice a lot actually to get it to right for the steps actually. Like first we need to define the epochs, then total loss for each batch in the loader. So where was the loader? It was the data loader, which gives the data in batches. Next we try to do the optimizer zero gradient. Then it does the forward pass here. Then we find the loss and then the backward pass. So it is just doing the same loop here only. Then we find the average loss and append it to total loss. Next, for each epoch, we want to print it. So let's see how it runs. For epoch 0, the loss was 2572. Then it was 300, 229. So it is being optimized. Our goal is to minimize the loss actually. So our initial epoch was 300, so it will run till 300. Let's see how it runs. So our code has run actually. So now let's go for the plotting. So we already did the Fourier transform. Then we also did k-means clustering and we also did neural networks. So as you can see the result, it's actually quite good. We can, for Fourier transform, we are getting, if you see slightly this kind of shape, like this bell kind of, the bow tie kind of shape. So this is indication of some kind of anomalies there, but it is not actually clear. So Fourier transform can't be used here to actually predict what is happening. And for k-means clustering, you can easily see there are two zones, two clusters, and for even for neural network, we can see two clusters. So these two are matching. Actually, this is the correct way. So this was all for today. Actually, what is our general workflow in the data, how we use ML in geosciences. So I've already showed you how we work in well-log data, how if it is for the self-potential data, if it is for the here gravity data. Why I've not shown you the seismic data? Because seismic data is very large actually. Its files are 100 MBs or GBs in size. So if we want to work with ML models on these seismic data, so it requires a lot of computation and time. So the model will keep training on for hours and days, even for minimally minutes. Here it was done in seconds. So this is why I did not show you the seismic work. So now if you have any doubt, you can ask just by unmuting yourself. There's no need to write on chat. So here are the acknowledgements. I've taken some from net. If you have any doubts, you can mail to me and get to me by LinkedIn or email. So yeah, now you can ask anything. Is there no doubt? Is there any possible sonar imaging? Yeah, it is possible. Let's say for sonar imaging, it's similar to seismic. You need to define the initial wavelet, sound wave, and the geometry also. So for this kind of stuff, you can use Devito library actually. Let me show you. So this is a good library to work for modeling actually. There are also PyGimni named some libraries which you can use for modeling. So yeah, synthetic data can be easily created. So here also, as you see, this was also synthetic creation data. I created my data with the help of this function. So you can also create all kinds of data synthetically. So yeah, it is possible. Any more doubt?
If anyone has any doubts, they can ask through the microphone as well. No need to write.
Yeah,
I guess that is it then. Thank you so much, Raj. This was a very informative session, and we got to learn so much. And this
yeah.
uh,
I would
and
request
hands-on
everyone to,
library.
yeah, yeah, wait, please don't leave. Actually, I would request everyone to turn on their videos and let us have a photo actually. So if you would all turn on your cameras. Quick, guys, I can see only few photos. And if you have any doubt, you can get through me later also. Not if you are hesitating to speak or shy to speak about. Okay, I have taken the image. Now, if you don't have any doubt or you are free to leave, you can continue on Manas.
Yes, thank you very much, Raj.
Yeah.
And I hope any doubts that these people further have can ask through the mail ID. Uh, Thank you very much.
Yeah, we'll be also uploading a YouTube video of this recording session, so you can get it by WhatsApp also later on.
You guys can quit now.
Hey, can I ask where I can get the certificate?
We'll mail it to you.
Okay, thank you, sir.
You have filled the Google form, right?
Yeah,
Yeah, so you'll get the certificate by the mail.
okay, sir.
Okay,
I think
thank you very
someone
much.
asked. I think someone asked questions in the chat box.
Yeah, I saw it actually. Actually, I'm not sure when I'll get the if we will having if we will be having a new class or not. Let's see with the team what happens. Okay, then bye guys. If you guys don't have any doubt, bye all.